All right. Um, Allow me invite you all senior threes for our geography lesson. I hope this is our first geography lesson in this session of this program. And I want to welcome you to this lesson today. And specifically, we are going to study the geography of East Africa, physical geography to be particular, aware of the fact that the different streams are trading at different levels. We have not yet harmonized the level of coverage. I want to uh, suggest that we pick a topic that we all need to follow consistently at the same level. Because I'm aware there are people who are studying glaciation, there are those who are studying volcanicity, because we have not yet harmonized the topics that we are covering as regards paper one. Some streams are slightly ahead than the others. So I am inviting you to a new topic that seems to be bringing us to the same level. And this topic is coastal landforms. So we have uploaded information regarding this topic. Though it's not the whole of it, we're going to have it bit by bit. And some of the information that we are going through or that we are introducing ourselves to this topic with is already uploaded, and you can also access it on your screens as the lesson goes on. Coastal landforms, or you can also call it coastal geomorphology. Know that geomorphology is the study of the processes that lead to formation of landforms. So when we say coastal geomorphology, we are referring to the processes that lead to formation of landforms along the coast. And morphology means the shape, structure. So the shape, the structure of the coast is what we want to look at. Because coastal areas have different shapes or different structures that we regard as landforms or features. Now, these landforms or features develop as a result of a number of processes. And when we look at these processes, then we are looking at what we are terming as coastal morphology. But I want to bring it out as coastal landforms basically, because what our focus will be is these landforms that exist along a coast. Now, before we go any further, we need to know what a coast is. A coast is a land or a piece of land, or it refers to land that borders a water body. Now, when we say water body, we are only talking about either the sea or a lake in this case, because we are not really talking about a river in this here. So we are talking about land bordering a sea or a lake. So that's what we call a coast. And the word sea here is used to mean these extensive water bodies. You can also call them oceans. And then we also have the lakes, because the nature of the water surface of the sea and that of the lake is similar. Because in both, we have water which is still, water which is calm, water which is not moving. It only moves because of some forces that we are yet to see. So that area, that land that borders the sea or the lake, is what we are referring to as the coast. So the landforms that exist along that area are the ones that we refer to as coastal landforms. Now, these landforms form basically through, I would say, or are categorized into 4 basic groups. Now, along the coast, we have an aspect of waves. And so, what waves do along the coast is what we are going to term as a wave action. Because I said that water within the sea or in a lake does not flow just like, unlike the water of the river. In a river, water flows or runs. In the sea or the lake, water does not run. It only moves because of the action of waves. When we see water of the sea or of the lake coming towards the coast, then that movement of the water is what we are calling the wave. So the movement of the water towards the coast, or its movement from the coast back to the sea or the lake, is an influence that is caused by wave action. And as waves make water in the sea to move towards the coast or to move back into the sea or the lake from the coast, there are 2 aspects that arise in this situation. That waves, in doing so, in pushing water towards the coast and then drawing water back to the sea or the lake, we have 2 actions. One is called wave erosion, and then the other is called wave deposition. So as the waves push the water towards the coast, that water hits the coast, and when it hits the coast, it is capable of breaking loose rock particles from the coast. And then those particles are then moved away by the water as it goes back into the lake or into the sea. So in that way, we have wave erosion. And then the materials that the waves carry will eventually be brought along the coast. And when they are laid there, they accumulate, and that's what we call wave deposition. So the landforms, we are categorizing landforms, therefore, that these landforms along the coast that we are calling coastal landforms are either as a result of wave erosion or a result of wave deposition, and the 2 fall under what we are terming as wave action. So we have category 1 of the landforms along the coast due to wave erosion, and category 2 of the landforms along the coast as a result of wave deposition. Then the other category 3 that we shall look at, category of landforms that form along the coast, are those that form as a result of what we are going to call sea level changes. Sea level changes mean variations, the rise and fall in the level of water within the lake or the sea in relation to the coast. Because there are times when water levels rise. You remember of recent, that was last year, there was a general outcry. People that live along the shores of Lake Victoria, much of the areas along Lake Victoria were submerged because of the rising levels of the waters of Lake Victoria. The same applied to Lake Albert. So there was a rise in sea level. That's what we are calling sea level rise. So it's an aspect of sea level change. And during some instances, you will find that areas along the coast, that land bordering the sea or the lake, that were formerly underwater may eventually appear above the water. Why? Because the water levels have gone down. So there is a fall in the water level or a rise in the water level. So those 2 are termed as sea level changes. So sea level changes refer to rise or fall in the water levels within the sea or the lake in relation to the coast. So that process also influences or leads to the formation of landforms along the coast. We shall be talking about landforms of coastal emergency. Okay. We have coastal submergence first. And then we shall also have those that form as a result of coastal submergence. No, that is emergency. Submergence means that the coast is submerged. The coast is now covered by the water of the sea or of the lake because of rise in sea level. Like what I've said happened March of last year, 2020. There was a rise in the water levels along the shores of Lake Victoria. Most places, those beaches were all submerged. So that when they are flooded with the waters of the lake because of the rise in the water levels, then that's what we call coastal submergence. And then coastal emergency occurs when the water levels drop or fall. Maybe during the season of prolonged drought, there's no rain, there is less water flowing into the lake or into the sea, so the water levels may drop. And that means that areas that were formerly covered by the water of the lake or the sea now appear above the water level. And that's what we shall term as a coastal emergency. So the coast emerges out of the water. Then the other one, we are saying the coast is submerged by the water. Then the other category, let me call it a category though, is number 4. Among the landforms that we find along the coast are those that relate to coral reefs. Remember when you were studying the topic of rock formation, we gave coral reefs or coral rocks as an example of sedimentary rocks that form as a result of deposition and accumulation of remains of dead organic materials that are derived from some tiny water organisms or marine organisms called polyps. So those ones form rocks that are rich in calcium carbonate, limestone rocks. But those rock structures that form along the coast because of the accumulation of these polyps or skeletons of these water animals called polyps are what we refer to as coral reefs. They are simply rock structures, rock pillars that form along the coast. And that is especially or not just especially, but they only form in the waters of the sea. Before we go any further, so we are saying these are the 4 categories of landforms that we have to look at. So we shall be looking at landforms due to wave erosion, landforms due to wave deposition, landforms due to sea level changes, which are also broken down into coastal submergence and coastal emergency landforms. Then we shall look at the coral reefs. These are all important aspects if we have to study and understand the geomorphology or the geography or the physical geography of the coast. We are using the word coast like we defined earlier, that the coast is that land that borders the lake or the sea. And it would puzzle somebody when we talk about a lake and then we're talking about a coast. In the context of physical geography, we are using the word coast intentionally. It's not a mistake because if you go by English, then the lake does not have the coast. The lake is supposed to have a shore. So we only talk about lake shores. We cannot talk of lake coast. But in the context of physical geography and specifically in the understanding of coastal geomorphology, we are also referring to the shores because this is now the shore is the land bordering the lake, to be specific. And then the English definition will tell you that a coast is that land that borders the sea or the ocean only. But in this context, we are bringing these ones together and referring to them as a coast. Why? Because the processes that we are looking at that lead to formation of these landforms are the same. The process that take place on the sea or on the ocean surface are the same or similar to the process that take place on the surface of the lake. So we are using this geographically that even the lake has a coast because it is simply land that borders a water body, and the water body in this context, as I said earlier, is either a lake or a sea or ocean. Therefore, we are going to pick category by category. That's why I said we are going to have these ones bit by bit. So the information that is uploaded is only referring to those landforms that arise from wave erosion. So specifically, today we are going to look at the effect of wave erosion and the formation of coastal landforms in East Africa. And in East Africa, we are saying along the coast of East Africa as well as along shores of lakes that we have in East Africa, as we shall see the examples of these landforms. So we are talking about wave erosion. As I've earlier mentioned, that as the water moves towards the coast, that water is going nowhere. The moment it gets to the coast, that land bordering the ocean or the lake, it hits or it knocks on that land and then goes back into the sea. So the motion, the movement of water within the sea or the lake is basically ending at the coast, unlike the waters of the river that flows from the source to the mouth. So the water continues flowing. So in this case, the water is only within the same position because we are in a basin or a depression in which the water is moving. But before we go into the details of this action of waves, which is called wave erosion, we need to understand what a wave is. A wave is an oscillation of water. To oscillate means to move up and down. So water within the sea or the ocean moves up and down towards the coast. So the oscillations of water, or you're saying waves, are oscillations of water on the surface of the sea or the lake. So as the water oscillates, moves up and down towards the coast, that's what we call a wave. Now, what makes this water move towards the coast? Because we said the water within a lake or a sea is not in motion. It's not because it is just water contained in a basin or a depression that exists on the surface of the earth. But what makes it move then towards the coast? So the force behind the movement of water towards the coast, that therefore creating a wave, is the wind. So wind movement. So the wind blowing on the water surface forces this water to also move in the same direction of the wind. I want us to only understand this in one concept, because the direction may not necessarily be from the sea towards the coast only. It may even be moving along the coast. So all that will be still an oscillation that will be created because of the force of the wind. So as the wind blows over the water surface from the lake towards the sea, or from the sea towards the land, lake towards the land, or sea towards the land, as that wind blows, its weight exerted onto the surface of the water makes that water also move in the same direction of the wind. So the major cause of these oscillations that we are calling waves on the water surface is the effect of wind that blows over the water surface. So as the wind comes towards the land surface, the water also advances or moves towards the coast. And that water, said as it comes, it is going nowhere. The moment it reaches the coast, then it knocks on the coast and then goes back or flows back into the ocean or into the lake. So it's just movement to the coast and back to the sea or the lake. Now, in doing this, in these movements, we use two terms to describe these movements. And these two terms are what we call the swash. Swash, this is the water advance towards the coast. So, as the wind blows towards the coast, the water also follows it, and therefore, that forward movement of water from the sea or from the lake towards the coast is what we are calling the swash, or you can call it wave swash. And when you are at the coast or at the lake shore, you always hear that sound. There is always a sound that the water will create as it hits the coast. So there is a rhythmic sound that water blows. That water makes as it hits the coast. Actually, you may even feel it is making that word or pronouncing that word swash. So it continuously moves towards the coast. So that's what we call the swash. So the forward movement of water towards the coast from the sea or from the lake is what we are calling a wave swash or a swash. And then, as we say, that when the water hits the coast, then it draws back into the sea. So that movement of water back into the sea after hitting or knocking the coast is what we call we're going to call that one the backwash. So this is, you can call it retreat of water back into the sea. That after the water hitting the coast, it draws back into the sea. So there is a forward movement called the swash, followed by a retreat or backward movement into the sea, which is called the backwash. Those we should know where they would write the notes for coastal landmarks. Regardless of which topic you're covering, we are saying this is a new topic that brings us all together at the same level or same footing. So just create space for the topic that you are handling, then you start a new topic, which is coastal landform. So in the notebook, not in the summary book, because the notes that I've provided that have been uploaded are already arranged notes. They are not in summary. They are notes that you need to have in your book for further revision. So we are saying the swash and the backwash occur during the wave movement, the oscillations. So now we say that waves are caused by wind, but in some cases we can also have waves occurring because of other factors. And I can point out two major causes of waves other than wind blowing over the water surface. One of them is catastrophic events. And I say this is no catastrophes. We have catastrophic events. What are these? For example, recently we had the catastrophe in the DRC of Nyiragongo Mountain erupting. That is a catastrophe. So that is a catastrophic event. So these events, for example, we have earthquakes. When an earthquake occurs, there is a shaking or tremors that are created by the earthquake. If this happens on the bottom of the lake or on the bottom of the sea, so it means that the water within this basin or within this depression will also begin to shake. And in the process, as it shakes, that water will flow. It will start moving towards the coast, hit the coast, and then blows back. So that could be a cause. The other one could also be volcanistic. there was some. Uh, it was running actually you can go on YouTube. They were showing volcanic eruption in Lake Kivu. So when a volcano or when volcanic action takes place on the bottom or on the bed of the lake or on the sea, then the lava coming out will start to make the water to move towards the coast. So such events may also cause uh, uh, oscillations of water towards the coast, and therefore can be a cause of waves. So the other, maybe even before we go, you try an example. If you have some, maybe you go to a swimming pool, or you can even just have water in a basin full of water. Just get a stone and drop it into that basin. You'll see waves flowing to the sides of the basin. So it implies that that shaking or that water, I mean that stone that hits the water will create or will ignite waves to start flowing and moving. So that's what happens. That even earthquakes or volcanicity within the lake or the sea will create those waves that result into water movement towards the coast. Then the other cause could be movement of objects. So large objects moving on or within the sea. In the lake or sea, when those objects are moving, of course, they will also start to push water as they move, either within or on the sea surface. They move the water, and so as the water is pushed, it starts to oscillate towards the coast. So these large objects could be, for example, a ship or a vessel, a large vessel moving on the water. So it pushes the water, and that water may start moving with those oscillations in form of waves. Or we can even have aquatic animals, large aquatic animals like whales, as they swim within the water. They may also send off forward movement of water in the form of oscillations that we have described as waves. Now, those that can access the notes, we have a simple illustration of the structure of a wave. The structure of a wave. Just have something in this nature. That as this water flows, so we have this is it rises, so the water rises and then drops again, then rises, then drops, rises, drops. But you'll see that as it goes towards the coast, as it comes near the coast, the height of the rising of the water reduces. So the wave comes when it is so high, but as it comes towards the coast, it now reduces, then it hits the coast. And so the wave breaks at some point as it comes towards the coast. And then when that water hits the coast, then it goes back into the ocean or into the lake. Now, this rising here, this part that rises, is called the crest. So the wave crest. Now, between this rise and this one, we have what we call the wavelength. So the wave moves in form of crest. So these crests are then oscillations, ups and downs. So we have a crest, that's the up, then it drops, then it again rises in that form as it goes towards the coast. So that is a simple structure of the wave and how water moves in form of what we are calling the oscillations, the ups and downs. What are these landforms? The landforms that form along the coast as a result of wave erosion, because we are looking at wave erosion as one of the process or the actions that take place along the coast to form landforms. So our target is what landforms develop as a result of wave erosion along the coast. Now, these landforms are quite many, but I prefer to arrange them into 3 categories for easy understanding, simply because these categories will help us understand, because each category is a collection of landforms that are related in a way they form. Now, I'm putting these landforms into 3 families. The first family of these landforms will include what we shall call the cliff, and then this goes hand in hand with what we are going to call a wave cut platform. So it is a family of 2. That we have a cliff, and when the cliff forms, then there will definitely be the formation of a wave cut platform. So those 2 form concurrently, I would say. That's why I want to bring them as one category of landforms arising from wave erosion. Then the other category, let me first give these categories. The second category or family is of 3. This category includes a cave. Then it has another one called a blowhole. And then a third category, a third member of this family is called a geo. So we have cave, blowhole, and geo. So those are 3. That when the cave forms, there is likelihood that we shall have a blowhole forming. And where the cave is where the geo will form, as we shall see. So those 3 are almost formed in a similar way. So one leads to formation of the other. Then, because you cannot have this without this, as we shall see. Then, the third family, this one is quite a large one. This family has what we shall call the bed. To have what we shall call the headland. We shall have what we shall call the arch. To have what we call the stack, and then another member called the stump. So this one has 5. This one has 3, and the other has 2. So we have 2, 3, and 5 in categories, because these ones, when these ones form, then you are likely to have these other ones also coming or following. So these are the 3 categories of landforms. I'm saying categories because I don't want to scare you by mentioning 1, 2, 3, 4, 5, 6, 7, 8, 9. There are so many. But we are bringing them into categories for easy understanding. And if you group them that way, they will be easy for you to understand and explain how they form. So let's quickly go through these landforms. The first one, therefore, is the cliff. So in category number 1, or family number 1, coastal landforms that form as a result of wave erosion. So the first one is called a cliff. When you go, those who have been to places like where they do bungee jumping, maybe on the side or on the bank of the river, you have a very steep side of the river, and then people will now do bungee jumping from that bank or side of the river down as they go into the river, or into the river, actually touching the river. water from up. So that side of the river, which is very steep, steep, is what we can call a river cliff, because a river also may have a cliff when you have a river which has a side which is very steep or vertical. So in this case, we are not talking about that case of the river, we are talking about a coast or a shore for that matter. So along the coast, you may have a steep surface, a steep rock face. And that steep rock face is what we call a cliff or a coastal cliff. So we can describe it as a steep rock face along the coast. So our cliff, simply a steep rock face which is found along the coast. So on the sides of the river, on the sides of the lake or the sea, you find a steep rock surface. That steep or vertical rock surface is what we simply calling the cliff, and it lies above the water level. So we always use the word it overlooks the water surface, because it is above the water level. So it is. So if like you have this wall or this board here, and if the water level is here, so this is the side of the coast. So this is the coast, and if this is water, then it means that this slope here is overlooking, is hanging above the water level, and that's what we are calling the cliff. How does this cliff form? In simple terms, we are saying these landforms, all these landforms are formed as a result of wave erosion. So it is because of wave erosion along the coast that we shall have a cliff forming. But how does it form? That along the coast, waves may erode through. There's one thing that we omitted, and I beg that we first quickly mention this aspect, that wave erosion, it is the good thing to capture within the notes. Wave erosion takes place through processes. We'll explain these ones. So the process of wave erosion, let's put this one down here first. So this process of wave erosion, because waves don't just erode in the same way, they erode in different ways. So there are basically 4 processes. One is called hydraulic action. The other one is called abrasion, or you can call it corrosion. The third one is called solution, or you can call it corrosion. And then there is another one called attrition. So I beg your pardon, we have omitted that one because it is very important. But before we start to explain the formation of these landforms, we need to mention these processes. One of the processes I'm saying is called hydraulic action, the force of water hitting the coast. As that water comes towards the coast, it hits or knocks the coast with force. So the force of that water is capable of breaking rock particles from the coast, and those particles are taken away. And so that's what we are calling hydraulic action. In the same way, as that water comes, it compresses air within the rock cracks or joints. And then when that air is compressed within the cracks, then the rocks are forced to expand and therefore break. And as they break, the broken particles will then be taken away by the wave through the backwash. Remember we talked about the advance of water, which is the swash, and then the backwash. So when the rocks are broken, the particles that are broken will be taken back into the sea or taken away into the sea by the backwash, because now that water retreating goes with the broken rock particles. So that is hydraulic action. Then the other process is called abrasion or corrosion. That as that water, for example, during the forward movement, the water comes, breaks the particle through hydraulic action. So the backwash takes them. But before the particles that are being taken by the backwash reach any further, another wave is coming. And that wave comes and it again pushes back these particles that were being carried by the backwash. And then those particles will be contained within the swash. So the swash comes with rock particles in it. So it throws those rock particles onto the coast. And so those rock particles that the swash is coming with will again hit the coast and then break other rock particles from it. So that's what we call abrasion or corrosion. So the wave or the swash is using the rock particles as a eroding tool. So those rock particles acting as hammers, they're the one who's hitting the coastal rocks and breaking other loose rock particles from it, which will eventually again be taken by the backwash. So that gives us a process that we are terming as abrasion. Then the third process is called solution, just like the name suggests, or corrosion. Something is corrosive. So these are minerals or rock materials that are soluble in water. So as the swash washes, or as the water washes these rocks along the coast, those rocks, the soluble minerals, are dissolved in water and they will be taken away in solution form. So in all this, it means that we shall see now the coast extending backwards because now the rocks are being dissolved and carried away in solution form. So that's what we are calling solution, action, or corrosion process. And then there is the fourth one, which is indirect, that is called attrition. The attrition process is indirect in the sense that now those particles that have been carried from the coast, that have been eroded and then being carried by the wave, either the backwash or being brought by the swash, in the process of being moved within the water, those particles keep colliding with one another. They hit each other. So as they collide within the water with each other, those particles further break down into smaller particles. So it is the process by which the rock materials being carried by the waves hit and collide with each other, further breaking down into smaller particles. That is the attrition. So these are the processes that I wanted to us to first of all look at before we explain these landforms. So there's hydraulic action, the force of that water, and that force again also compressing air within rock cracks, which causes expansion and therefore widening of rock joints or cracks, which lead to breakdown of rocks, which will eventually be carried away. Abrasion, the particles the water is carrying, or the wave waters are carrying, those particles hit the coast and then break other loose particles from it. Solution, minerals or materials within the rocks get dissolved in water, taken out in solution form. Attrition, the particles within the waves also hitting with each other and therefore breaking further into smaller particles. So that is what we have omitted here. But now going back to the landforms, we said we were talking about the cliff. I already explained the cliff as a steep rock face along the coast. Steep rock face along the coast, or it hangs above the water level. And we are saying that this landform or feature forms basically along the coast where there could be lines of weakness or cracks. And then when the wave comes, the line of weakness or the crack becomes a point where the wave can easily erode. Remember, for example, we said the hydraulic action that is compressed within the cracks. So the cracks become widened because of the compressing of the air within it. So they break. So it is easy for the wave to drill a hole, to drill an opening along the line of weakness or the crack. And that opening is what we shall call a notch. So when an opening develops along the coast, then that opening is what we are terming as the notch. So if this was our coast, so assuming this is the water level, so this is our coast. So as the waves come, they erode. So they create an opening here, which develops into the coast. So this opening is what we are calling the notch. A small opening. It's not a cave yet. It's just an opening along the coast because of the line of weakness that exists there. So as this notch extends into the coast or grows, then it means that this block, this rock above, will be hanging and it has no support below because there is an opening below. There is just open space down here. So it means that this rock may eventually become too heavy to rest at this point. So what happens is that this part here may eventually collapse. And when it collapses, it means that this part here that may have been relatively gently sloping turns into a vertical slope that we shall call the cliff. And our illustration there simply so when the roof of the notch collapses, I have something. You're able to see this. So along the coast we have this vertical slope. Why? Because the materials that were here have dropped here. So that steep rock face here is what we call the cliff. There's a clear illustration in our notes. So this is our cliff. I've chosen to draw this three-dimensional diagram, but you can draw a two-dimensional, which is very simple. Simply do something like this. So this is water, and this is our. So remember, it was formerly like this, but because the notch developed here, this part collapsed. So this is what we are calling. So this is the sea or the lake. So this is the cliff, a steep rock face above the water level. Now we have said that the materials above or the rock above the notch collapses, and where does it go? These materials, when they collapse, they accumulate here. They fall here. And even after the formation of this cliff, because of this steep slope, and the waves are continuously hitting the coast and that cliff. So you have loose particles of materials or rocks falling down here. So when those materials accumulate here, they form a platform. They form an area which is covered by rock materials. So this is what we are going to call the wave cut platform. So that's why I chose to bring these two together, because when you have the cliff forming, definitely the wave cut platform comes into existence. So the cliff, the formation of the cliff results into the formation of the wave cut platform. So the wave cut platform is simply that gently sloping surface at the base of the cliff. So the cliff is a steep rock face, but at the base, at the bottom of the cliff, we have a wave cut platform, which forms as out of accumulation of materials at the base of the cliff. Now, we're saying these materials are a result of the collapse of rocks above the notch during the formation of the cliff, as well as erosion that takes place on the cliff face. So those materials accumulate there and form that platform that we're calling wave cut platform. There are several of such features, especially along the coast of East Africa, at some place called Fort Jesus. Those who you have heard of this, Fort Jesus. So near Fort Jesus in Mombasa, that is along the Kenyan coast. Even at Kilwa, we also have another fort there called Fort Gaza near Kilwa. So we have cliffs, and where the cliff is, we are demonstrating that where the cliff is, there is always a wave cut platform. So those ones form hand in hand. So we are saying Fort Jesus. We have there cliff. We have another one at Fort Gaza. So we said this is Mombasa, Kenya. This is at Kilwa. It's also Kenyan coast. Then even when you go to Kassim, Yes, there is a display on your screen indicating Fort Jesus. Is, that's not just an illustration. It is actually a picture that shows uh, how steep that one of Fort Jesus is. So yeah, so you can see Fort Jesus. Fort Jesus, that structure behind, but you can see a steep rock on the sides. That is the vertical slope that we're talking about that shows the cliff. So the materials at the base, at the bottom of the cliff, are the ones that form what we are calling uh, wave cut platform. So those are examples. And I was also saying that when you go to casting, you also have a cliff on the end, on the side of there is one side of Casting Fishland side. Uh, there is a headland which is called the Nakasunda headland. On its sides, it has a very steep surface, which also represents a cliff. And when you check at its bottom, you will see when you go to Kasen, you also have, I was explaining, when at Kasen, you also have a steep rock face on one of the headlands. To the west of the landing site, there is a very steep rock face, which is also an example of a cliff. So cliffs and wave cut platform form that way. So it is basically usually is out of hydraulic action uh, that creates a notch along the coast, and then the materials above the notch will eventually collapse. And when they collapse, they leave a steep rock face above the water level, and then at the bottom where the materials collapse, they form a wave cut platform. We go to therefore the second family of coastal landforms arising from wave erosion, and this is a category which has the cave, the blowhole, and the gill. And because these ones are also formed most in related form, we need to look at them together. Now, a cave, our cave is a horizontal tunnel. Horizontal tunnel that extends into the coast. We all know a tunnel. If, for example, if you dug a hole, maybe if you had the hill, then you create a tunnel. You've heard of, or you have seen on TV or where on movies where those underground roads or tunnels used by railways or even because they are roads, especially in those mountainous areas. Those that have had a chance to go to Kirembe mines, we have tunnels that have been excavated to extract the copper. Now, along the coast, you have such a feature, an opening, a tunnel which is horizontal but running into or going into the coast. So if this is our coast, then there is a hole that extends into that coast. That's what we call a cave, or you can call it a coastal cave if you want, just to show that we are only talking about that cliff, that cave that forms along the coast. So if you are going to say it is a horizontal tunnel that extends into the coast. Now, How does this form? It also forms through the process of wave erosion and basically hydraulic action and solution. That if you have, like we said, for the case of a cliff where you have a line of weakness where the waves can easily erode. So if that line of weakness or crack along the coast develops or widens and further deepens horizontally into the coast, then it forms that tunnel that we are calling cave along the coast. It could also be because of solution action of waves, that maybe that section there has soluble rocks. Because we said one of the features that form along the coast, or that are common along the coast, are coral reefs. And coral reefs are made up of calcium carbonate, which is limestone, which limestone is soluble in water, so it dissolves in water. So if you have an area that is predominantly or majorly made up of those soluble rocks, so the waves, as they hit that area, the soluble minerals are eroded away in solution form. Therefore, that area easily develops into a tunnel that we are calling a cave. So, our cave, when that cave forms, we have that opening into horizontal opening into the coast. So, as water continues to come in the form of swashes, when that water enters that hole or that tunnel, it gets in there and then splashes. So when it hits the end, it splashes and then it moves up and then draws back. So as it does so, it splashes within the cave. As the water splashes within the cave upwards, it is also gradually eroding the upper part of that cave. So gradually we see an opening, a shaft-like opening, a vertical opening developing through the roof of the cave. So that part, that rock covering the cave, the upper part of the cave is what you're terming as the roof of the cave, or the cave roof. So when that hole develops through the roof of the cave and eventually appears on top of the coastal rock, then that opening is what we are going to call the blowhole. So our blowhole also forms. So this is we shall call it a vertical opening through the roof of the cave. So a vertical opening through the roof of the cave forms because of the water keeping on splashing upwards, and by doing so, it is kind of what we call hydraulic action. So the cave has formed, and after its formation, continually splashing the water through hydraulic action into the cave, drills a hole through its roof, and therefore we shall have a blowhole forming. We have that illustration also. The illustration of the cave and the blowhole together is also provided to us. Let me try to do something here. This was you have the illustrations well drawn there in the notes. So if this was the water, so here we have the sea. That means that here we have the coast. So have something like this. So if this water coming up this point, so this area here has an opening that projects, horizontal opening that goes into the coast. So within here, as the water goes into that hole, so here we have the sea, so this is our cave. Now, at some point within the cave, then as the water splashes upwards, it drills that hole through the roof of the cave. So this is what's going to appear on the top of the coastal rock. And this is what you're going to call the blowhole. So it means that this hole here connects the cave down. So the cave and the blowhole form jointly. Now, further, you'll see that as even after the formation of this blowhole connecting the cave down, the water still continues. The swashes continue entering into this cave. And that means that as it also splashes up, we may find that the entire roof of the cave is gradually eroded and weakened. So what happens is that this roof of the cave may eventually collapse. And when it collapses, it means that we shall have a narrow opening, a narrow projection of now the water of the sea into the coast. So that section that was formerly a cave now becomes an open entrance or open inlet into the coast. And that open inlet is what we are calling, is what we are going to call the geo. So if this so this is so we had assuming we had the blowhole there. This was the cave opening. So we get eventually this. So this was a former cave, extent of the cave. So when the roof of that cave collapses, means that this area becomes open. So we shall have a narrow, sided sea inlet into the coast. So this is like an extension of the sea into the coast, which is a narrow inlet that we are referring to as the Gio. Now you can see that the three. So this was our former cave. So this is now our view. You see that the formation of the cave eventually gives way for the formation of the blowhole. And the same actions that brought about the formation of the blowhole may continue within the cave and therefore leading to the collapse of the roof of the cave to form the geo. So the three are said to be in the same family simply because of the fact that the process or the mechanism of formation is from one to the other. So you cannot have, for example, the blowhole without a cave. And you cannot also have a geo forming where there is no cave. So it begins with the cave into blowhole and then eventually you have the geo also forms. The last questions for this, that is our illustration in the notes, combine the cave and the blowhole, and then we also had a separate one for the geo after the collapse because we could not show the geo together with the others because the geo only appears after the roof of the cave has collapsed. And in East Africa, these landforms also exist. Examples that we can look at we have caves at Kasenyi and the Kibanga on the shores of Lake Victoria. So Kasenyi and Kibanga. Kibanga is also on the shores of Lake Victoria. Kibanga, I think, is Mukono, one of those now. So you have on the shores of Lake Victoria, you have these tunnels that we are calling caves. We also have them along the coast of East Africa, for example, at Kilifi and Tanga. Why Kilifi and Tanga? These places have got coral reefs. Yeah, they are images of caves. Images of caves here. This one that we're showing there. That's a tunnel-like opening along the coast. That's what we are calling a cave. We said when that forms, eventually we may have This one we are showing here is one in Maragambo Forest, although it is not a lake or a sea, but it is showing you a tunnel, horizontal tunnel. It is indicated there. It is found in Maramagambo with several bats. So that is an image showing you how a cave looks like. This one, another one there. And there is another cave there. You can see an opening, an extension into the rock. See that opening into the rock. So that can be the work of waves along the coast that drill that horizontal tunnel into the coast, which is called the cave. So having looked at that category also, we go to the third category or the third family of coastal landforms arising from wave erosion. And this category includes bays and headlands first. So, bays and headlands. Now, the bays and the headlands, these are common features along the coast because it is not common to find a coast which is straight all through. When you were studying fishing in British Columbia, one of the factors that you said has favored or has encouraged the development of the fishing industry there, on the fishing activity there, is the presence of an irregular coastline with the bays and headlands, meaning that the coast is not straight. So you have something of this nature. So if this is your coast, land border, so this side here you have the water, it means that there are sections where the land extends, where the coast extends into the water. This forms the headland. And there are sections where the water is projecting or extending into the land, which is the bay. Now, these bays and headlands are good in the sense that they shield or protect the coast against strong waves or currents. And for that matter, when fish want to lay eggs, to look for areas that have got protected waters which are calm, not disturbed so much by strong waves. So the bays and headlands are coastal features that are common everywhere. So in East Africa, we also have them on almost every water body, especially I'm talking about lakes and along the coast of East Africa. Yes, what is a bay? A bay is a sea projection into the coast. So we're saying this one here is sea or water projection into the coast. And then the headland, on the other hand, is the land projection into the sea. So here we have land projecting to the sea from the headland, and water projecting to the land from the bay. So bays and headlands are formed. How? This means that this area here, this coastal area, has alternating hard and soft rocks. Those rocks which are alternating are of different resistance are rocks that we term as heterogeneous rocks, non-uniform rocks, that they don't have the same resistance to wave erosion. So what would happen is that they are hard and soft rocks. So these sections here will have soft rocks, and these sections here have got hard rocks. So what we shall experience is what we are describing as the differential wave erosion, meaning that the waves are, I mean the rocks along the coast are eroded. The waves, I mean the rocks along this coast are eroded at different rates. So again, that's what we are terming as differential wave erosion along the coast, implying therefore that the soft rocks are easily eroded, and therefore those areas, sections that have got soft rocks, extend fast into the land, while the other areas or sections with hard rocks remain projected, because for them they are less eroded. They are eroded at a slow rate, so they remain extending or appearing to be extending into the water or into the sea or lake. So differential wave erosion due to differences in rock hardness results into formation of sea projections into the land where the rocks are soft, and land projections into the sea or the lake where the rocks are hard. There is an image that you can view on your screens of the headlands and bays. There's a beautiful one there that shows bays and headlands. Patient, you'll be able to see it. Headlands and bays. So there is that image there that clearly shows you land extending. You see the one in the middle, it's a land extension. Is that piece of land extending to the water. On either sides of it, there are extensions of water. You can see water extending to the coast, while in the middle, you see extension of land into the water. So the one in the middle there, that projection into the middle, is our headland, and then that water extension to the land on either side gives us the base. You can see the labels are there; those are headlands, and then there are those bays. So these ones are common in most parts of coastal areas of East Africa, and then along lake shores. Uh, we can talk of very many examples. We have Makshan Bay. You've heard of Makshan Bay. I'm not talking about Makshan Falls, but Makshan Bay is at Luzira. So there is a bay there called Makshan Bay at Luzira. This is an example of a bay. We have a bay at Kasenyi. So Kasenyi landing site is situated on a bay called Kasenyi Bay. We have one in Jinja where Masese fish landing site is situated. It is called Napoleon Gulf. We have another one in Kenya, common one, is called Homa Bay. And actually in Kenya, Homa Bay is a region, an entire region or province almost, called Homa Bay. So that area there also shows an example of a bay. And actually, all these ones that we are mentioning are found on the shores of Lake Victoria, including that one of Kisumu, because Kisumu is also on the shores of Lake Victoria in the Kenyan side. Then, among the headlands, I've been mentioning here a headland at Kasenyi, one called the Nakasunda Headland. There's also another one called the Buwanda Headland. There are two. On the western side of Kasenyi, there is a headland called Nakasunda. And then on the eastern side of it is another headland called the Buwanda Headland. So Buwanda and Nakasunda headlands are examples that we can see at the Kasenyi Fish Landing Site on the shores of Lake Victoria. Now, like we said, we have this family, we have already seen these two. That is the bay and the headland forming. Now, when you have a headland forming, then it so happens that this extension we try to bring this into perspective, assuming this is our coastal area. We have our headland and the base. So this becomes this is water. So this is our headland, and this is our bay. This is also a bay. So that projection of the land which forms the headland can be eroded from either sides, or it can even be one side. But if it is eroded from the sides, and maybe because of a line of weakness or because of presence of that is a line of weakness is a crack or a joint, or it could be because of some soluble rocks. So when that happens, so this is the side of this headland. Showing this is our headland into the water. So it has this steep side. Now, this is the top of it. Now, if erosion takes place from the sides of this headland, and then we find that a hole or a cave, for that matter, is drilled through. So our headland is drilled through by webs. So you have an opening that runs from one side of the headland to the other. So you have a tunnel across the headland, for that matter. So that passage or tunnel across the headland is what we call the arch. You've been to, for example, you've been to churches and mosques. When you see their doors and windows, they have arches. They construct them with arches at the top. So that is what we call that carving, that dome-shaped structure above the door or above the window, usually of a church or mosque. That's what we call an arch. So it's a similar structure that we have, but this time across the headland. So we call it the arch. So we can say the arch will not form unless you only have a headland. So the headland will give rise to an arch when it is attacked or eroded from either sides by webs, therefore drilling a passage across it. So we are saying the arch is a passage, is a bridge-like passage across the headland. So this is the passage across the headland. Across the headland. So this passage is created by wave erosion. So that adds another member to this family of landforms resulting from wave erosion along the coast. Now, gradually, because this passage has been created, as water keeps moving through it, like we said about the cave, that the water splashes in it. So this water may keep splashing within that passage. And that means that splashing water will erode the roof of the arch. The rock above the arch will be gradually weakened and it may eventually collapse. Now, when that rock collapses, it means that this part, assuming there was an arch here, assuming this headland was extending up this far. Now, when this part collapses, this part here collapses, this roof collapses. What happens? That this part of the headland, which was formerly part of it, will now remain isolated, detached it will be detached from the headland. And so that detached piece of the rock. So we're saying, assuming now this one is detached when that part there collapses. So when this part, the roof collapses, so our arch is no more. What happens is that now this seaward end, the seaward part of the headland has been cut off from the headland. So it forms what we shall call the stack. So this one turns into a stack. So we can see from the headland we have got an arch. Now from the arch, the stack has come into existence. So when the roof of the arch collapses, the stack comes into existence. Now, after this stack forming, again, it will not remain in that form forever. Because remember, the waves are continuing to wash it. They keep washing it, and as they wash it, they erode it. Now it gradually grows into a smaller rock. So when this one is worn away or is eroded down, so it may something that was that big may remain something very small because of wave erosion. So continue wave erosion on the stack will turn this one into a stamp. So a stamp is simply a remnant. It's a rock mass. It's a small mass of rock within the sea that remains after the stack has been eroded by wave action. While the stack is a rock that stands in the water that has been cut off from the headland after the collapse of the roof of the arch. So the passage, which is the passage across the headland, is the arch. When the roof of the arch collapses, we shall have the stack, which is a rock that has been cut off from the headland. Then, when the stack is gradually or further eroded down by wave action, then it remains a small rock mass, which is known as a stamp. So, the bed, the headland, the arch, the stack, and the stamp are another family of coastal landforms resulting from wave erosion that we can talk of here. So, in short, in summary, these are the landforms that are formed as a result of wave erosion along the coast. And that is, in simple terms, also the effect of wave erosion on landform development in East Africa with those various examples that we have looked at. And your attention should be put on categorization, not in this case of families and whatever, but the categorization of landforms that are found along the coast. Because we find most of these in the objective type questions. Which of the following landforms, which of the following coastal landforms is a result of wave erosion? And then they will bring there one landform which is due to wave erosion and others which are due to other processes like sea level changes that we have talked about, or wave deposition, or coral reefs. So somebody would identify any one of these. Simply somebody says geo is one of them, then puts another one, a beach, puts another one, maybe atoll, because that is the type of a coral reef, puts atoll, and then so that grouping will now we are testing to see whether you know the various processes that lead to formation of different coastal landforms. The other aspect that you need to pay attention to is the processes of wave erosion. We talked about four of them, that is hydraulic action, abrasion or corrosion, solution or corrosion, and attrition. Those are very important also. They are very important because they relate to other processes that lead to landform formation along the coast. So somebody will ask you which of the following is a process of wave erosion. Then we'll put one process, and then the others may be glacial processes, because you have looked at glaciation, basal sapping, blacking, abrasion is also there, under glacial erosional processes. So you'll find that somebody wants to test whether you can distinguish between processes of wave erosion and processes of glacial erosion, or process of river erosion and others. So we need to take note of these aspects. They are very important for us. The other aspect that you also need to look at, perhaps in a summary, the other aspects that you need to look at, though this is not very common, is how to explain the formation of some of these landforms that we have talked about. And the others that we are yet to see, because today we have only talked about those that are due to wave erosion. The next time we meet, inshallah, we shall be talking about those that form due to wave deposition and perhaps coral reefs. The other category that I talked about was landforms along the coast that form due to sea level changes. We may not go so much in the details, the rise and fall, but that is also very important. So, that I will emphasize this when we come to the last bit, that is the coral landforms. Because the coral landforms, we have, when you go to your question banks, for those that have them, you have a tube B, the geography, you discover that quite often, not once, not twice, they have asked about coral reefs. And that's another important area that I want us to. I didn't want to ask to rush so fast. So I wanted us to only handle that category of coastal landforms which arise from wave erosion. Because for those that arise from wave deposition are not too many, we shall see how to compress those ones and diffuse them together with the coral reefs. Of course, that's another interesting area that you always discover they have asked about. So I want to thank you for attending and paying attention, and I hope there are no questions that will remain unanswered. I believe if you have them, you would have brought them forward. Whereas for now, I want to say have a good day until we meet again for yet another geography lesson. Assalamu alaikum wa rahmatullahi wa barakatuh. Better.